Okay, perfect. Yeah, unfortunately, we have to switch to English, so I can't speak French. But anyway, I hope you can follow me. Yeah, this session is not related to the movie Wargames, right? And also not to the spy versus spy thing. So I don't know, the older ones remember maybe this, it was a comic. I don't know if it was popular in France, but it was in Germany. And it was spy versus spy, but I like the logo, and so I decided to take that. Okay, my name is Gerrit Grunwald. I'm working for Azul. We do JVMs. I do coding for, I don't know. I started in 1982 with my first computer, and that followed me along my path. And then at some point I studied physics, and then I worked in nanotechnology research and semiconductor industry for more than 10 years. And at one point, because I led the software development team, and that was only organization stuff and management and no coding. So, and I would like to code, so I left the company and I became a full-time software developer. And then at one point, I became like an evangelist, just traveling around talking about Java. So, and that's what I do today, about all kinds of topics. I'm a developer, as I said, so I'm not a security expert, right? Is someone of you a security expert? Oh, too bad. You probably know more than me. So, but at November 24th in 2021, this happened. I don't know if someone was affected by that. Yeah, probably you. Most of the developers somehow have been affected by that, and that made me think. Because to be honest, before that, I never really thought about security. For me, it was like I write my code, I throw it over the wall, and then some other people take care about security. So that's how it was for me. And like I said, I started in 1982. And in the 20th century, the software landscape when I grew up was totally different from that what we have today. Because in these days, it was we wrote everything ourselves, right? And everything was closed source because there was nothing like the internet, at least not in Germany for me. And then source code, we managed that in folders on our server somewhere, right? So that we copied stuff around. There was no Git and no other version control systems, at least not for my team and for my people. And everything we built was manually built. So there have been no build systems. So someone was, okay, I do now build, yes, and then his machine was blocked for half an hour and then the build was done. So, and we delivered hardware, the stuff on hardware like CDs and DVDs and USB sticks and all kinds of stuff, but it was always something physical. So there was nothing you just sent over the wire or download from a network. And everything ran on closed networks, right? So, or local servers. So there was not really, there have been some connections, but not really a lot. And in principle, it was large monolithic systems. Only connected systems at that time have been stuff in the government, banking, energy providers, but not really private companies, not that many. And we had the full control over the source code. That was the biggest thing, that is the biggest difference to today. So there was no open source at that time, not publicly available. So if you would like to have something, either you buy it or you code it. That was the way to go. So then the vulnerabilities also have been totally different at these days, because that was more password hacking and cracking. So you take a look at the trash can and try to find some nodes with some passwords and stuff like that. Was the stuff that was going on. There's the start of the first computer viruses and the early days of hacking via the internet at the end of the 20th century. And then time flies, and suddenly I found myself in the 21st century with Log4Shell, and stuff changed dramatically, because after that I took a look at the whole landscape and figured out that now everything or most of the code is open source. So who's using open source here in production? I guess all of you will do. And we have distributed source code management systems, automated build systems like CI/CD systems. The code is hosted somewhere in artifact repositories on the internet. Everything is running on public networks, accessible via browsers or APIs, and everything is connected these days. And we have a whole software supply chain that was not available in the 80s, right? This stuff. And we don't have the full control on the source code anymore. So because we rely on open source that was written by someone somewhere, we just trust it. It works. Someone told me it's good, so I take it. I heard that quite often. So yeah, someone told me this is a really good library. Yeah, okay, let's use it. So this is usually how it works. And the vulnerabilities are now totally different. So social engineering is by far the biggest danger that we have these days. And I was shocked when I read about SIM swapping. I don't know if you probably know it, but I don't know if you know what that is. When people can take over your SIM card in your phone, and then the whole two-factor authentication with your phone is useless, because if someone can take over your phone, then it's really dangerous. And we are all on social networks, and this is for me the biggest danger at the moment. And we have malware, ransomware everywhere. So I mean, we get spammed with all this crap, and everything that is connected will be hacked. You can be sure. I saw a hack where someone hacked a toothbrush, a Bluetooth toothbrush, and I was like, why? Just because he can. But that just shows you, right? If there's some API or something is connected, then some people get the idea, oh, let's hack the toothbrush, why not? So you can spread malicious code easier than ever before. The whole software supply chain is target of attacks. But to understand that, I stumbled upon a lot of these acronyms, because this is mainly coming from the US, and the Americans are terrible because they have acronyms for everything. And then, for example, it started with this CWE, common weakness enumeration. So didn't said anything to me. So this is a community developed list of software and hardware weakness types. And you find that if you have something like Log4Shell, you often find a CWE ID related to that. Right, so, and yeah, I have a lot of QR codes here. I can probably also provide the slides if you would like to have them as a PDF, then you don't have to take pictures from all of that. But that's sometimes quite useful. So you can look it up on the URL that is below here, or you just scan the code, it's the same one. But this is not the most important one. If we have these issues, right, like vulnerabilities, then it would be a good idea to have a place where they are stored publicly so that everybody can look it up. And this is the so-called NVD, that's the National Vulnerability Database. And it's run by the US government, and it's publicly available for everyone. They also have an API, so you can apply for a key and then you can access it with your own software. And it's a standards-based vulnerability management data represented using the security content automation protocol. Lots of this is all definitions, right? But it's good to know, if you know NVD, this is the database that stores all the vulnerabilities that are known on this planet, hopefully. And all of the security tools that you will find get the data mostly from there. Some bigger companies have their own databases, but this is like the big pool where all the stuff sits. So that means now we have a database, right, where we can store all the vulnerabilities. Now we have to somehow define them. And this is the so-called CVE. That's the common vulnerability and exposure. And you see already when people talk about that, security people, you might know that, all these acronyms, they throw it in the room, and if you have no idea, like, what are they talking about? So this is in principle, that's the definition for vulnerability. It's stored in the CVE. Right, and you will find it under cve.org. It's identify, define, and catalog publicly disclosed cybersecurity vulnerabilities. This is the definition of the CVE. And when we take a look at Log4Shell, because the developers only knew it as Log4Shell, but the security people know it as this. That's a CVE ID for the Log4Shell issue. And if I'm right, but you might be know better, but this is probably the year, and this is something like a running number at the end, I guess. So you can already see the numbers. There are lots of vulnerabilities in this database. This is more or less the key in the database where you will find the information to this. And this is the actual information for the Log4Shell issue. You don't have to read that, because I only would like to point out that it contains the versions that are affected. It contains the vulnerability itself, so it describes what is the attack here, what's happening, and it gives you a description of versions that are fixed or they're not fixed yet, and and these kind of things, and what is probably affected. And this is also the link to the log4shell CVE in the NVD. You see that's the NVD NIST gov and then vulnerabilities detail, and then you get the details for this specific CVE. And if you talk about vulnerabilities, then people talk about CVEs. This is, if you hear that, then it's always CVEs, more or less. You prove me wrong, but this is what I know. And now we have the database and we have the definition for a CVE, but somehow we have to have some kind of scoring system to tell the people it's a CVE, but it's not really harmful. This one is very critical, so we need some kind of a scoring system. This is a so-called CVSS, Common Vulnerability Severity Score. And this is always related with the CVE. So you have a CVE that has the ID and it has a CVSS score. And to make it a little bit more complex, there's not only one, but there are a couple in the meantime. So it started with the CVSS 2.0 standard, and it came with 3 levels like low, medium, and high. And you see there's the number system from 0 to 3.9, it was low, and then medium 4 to 6.9, high 7 to 10. And if you take a look at that, then you might already find it a little bit surprising that 0 is already a low vulnerability, right? That's somehow not correct. If it's 0, then there is nothing, right? Somehow they figured that out and changed the score. So this is the newer one. It's version 3.1, and last year in November, 4.0 came out, but it's the same scoring system. So with CVSS 3.1, the scoring changed, and you see now 0 is none, makes sense. And they now have also critical, low, medium, high, and critical. So if you find older CVEs in the NVD, they usually come with the 2.0 scoring, and the newer ones have both. So, and if someone tells you a CVSS score, then you have to ask him which one. Is it the old scoring system or the newer one? Because they are a little bit different. So, and usually it's stated with the score, but only the score alone doesn't really tell you anything. They are very similar, but they are not the same. So that means if we take a look at the log4shell one, in the old scoring that was 9.3, which was high, which is the highest one in the older scoring system, and in the new one it's critical, it's at 10.0. So that was a really high, it has a really high impact, this issue. And that was the first one. In Germany we have it's a TV news cast that is on the TV for, I don't know, as long as I can remember. And that's a very serious one, and it's very good, and everybody loves it because it's really the facts. And they reported about this. That was the first time in my life, and the only time yet, that this newscast was telling people something about log4shell. And that was surprising for me, and that just shows how high the impact was from that CVE. Okay, so that leads me to the question, is Java secure? Who is downloading Java from the internet here? JDK, probably all of you, right? Did you ever ask yourself if it's secure? Did you ever scan it? You just download it, right? Or you go to the Oracle page and download it, or to Tamarin or wherever, Azure, SAP, and then you use it, correct? And never ask yourself if someone ever scanned the code. You just trust it. Right? This is how it works. This is terrible in principle. I mean, you can be sure this is scanned, but still, people don't think about that. They just, I just download the latest version, and they just download it and run it usually, and they trust. Everything is secure. It's from Oracle. It should be secure. It's from Azure or whatever. They will take care about it, but you don't know, right? That's the big problem. But there is something that helps here. It's the OpenJDK vulnerability group. So there is a group inside of the OpenJDK project that takes care about vulnerabilities related to Java. So what it is, it's a private forum of trusted members of the OpenJDK community. So you can't just go there and say, I'm a security expert, I would like to work for this forum. Then they say no. They pick the people that they would like to have on this forum. And they receive and review reports of vulnerabilities in the OpenJDK codebase. So because it's an open source project, it has lots of contributors. That means you can't really make sure that everyone does it correctly. So somehow people check and scan the codebase, and if there is a problem, you can report it. And the process of reporting is not that easy. So, because you have to send an email, then you get some kind of certificate, and then with this certificate you can send another email to make sure that's really from you, and then you have to prepare some code that proves that this is a problem, and it's a really long process to get there. And then you shouldn't talk about it, because once this is public, suddenly Java would be vulnerable. So it's really, it's a quite closed system, which is a good thing. Right, so and if you really find problems, then they have a very good procedure to keep it as secret as possible and make sure that it's not someone who's trying to make some noise. They collaborate on fixing the issues. They don't really actually fix the issues, right? So just make sure that the contributors to OpenJDK fix the issues, right? But they coordinate the releases of such fixes, maintain the list of CVEs patched for each release. Who knows, or whoever saw the list, when there's a new OpenJDK release, there's always a list of CVEs that have been fixed. And I bet most of the people never really took a look at that. But we will come to that, because it's quite interesting. And they track also CVEs by component, because since JDK 9 we have a modular JDK. That means you don't need all the modules. So it makes sense that you track the CVEs per module, because maybe you just use 10 modules, and let's say the CVE attacks another module that's not in your JVM, so it's fine, right? So this is the reason why they track it by component. And they discuss OpenJDK security related issues, but they do not actively test the OpenJDK source code. This is done by the contributors and by the distributors, right? So we scan the code base, and we scan that as Azure, and everybody else will do. So and then there's this so-called OpenJDK vulnerability advisories, and this comes with every JDK release. So it means with each update. This is 4 times a year, and they describe the severities, the areas, and the affected versions of the CVEs that have been in the OpenJDK version that came out. So it looks like this. You might have seen that. Probably you see it and then you just scroll through. But this is, for example, that was for 1709, right? And then you see the list of CVEs. Yeah, you see the scoring, and you see this is CVSS 3.1, and you see which versions have been affected. And as you can see, the first one only affects 17, not 21, not 11, not 8. So these things, just because one Java version is vulnerable to a CVE doesn't mean all the versions are vulnerable. So it's really, it makes sense to take a look at this stuff, and this comes out with every update 4 times a year. It's shortly after or shortly before. And you can, if you just look for OpenJDK vulnerability advisories, you will find it. And then that leads me to the Java release cycle, because that also changed. In the former days it was like this, and that was terrible. And I started with 6 because that was the first version that was OpenJDK. Before that it was all closed source by Sun. And then this was the last update of JDK 6 was the first OpenJDK version. And then it took 4.5 years before we got JDK 7. That took forever. And then another 3 years before we got JDK 8, which was the first LTS release, long-term support version. That means you get longer support than for the other versions. And we will see on the next slide what that means, because then suddenly the whole system changed to this. So every 6 months, we now get a new release, but not all of these releases get long-term support. Long-term means for years. That means security patches for years. These versions only get updates for 6 months. And this one get updates for 10 years. That's the reason why if you work in a company, you should always, for your production system, stick to the LTS versions, because then you get security patches even in 10 years. JDK 8 is safe, I think it's 2032 or something. So to this date, you will get security patches for JDK 8. But if you go to JDK 10, because it came with a special feature, 6 months later, you are out of the game. You won't get any security patches for this version anymore. It's only 10, 10.01, 10.02, and that's it. And then there was 11, right? So that's even if Oracle says there is no long-term support versions, they don't like the term, but they offer this support longer for this version. So that means that everybody else does. So this is the long-term support versions. And then they changed the release cadence from 3 to 2 years, between 17 and 21. The reason for that is that this was quite some time. It was again 3 years. And these features came with some cool, or these versions came with some cool features. For example, in JDK 12, there came JPackage. That's a tool that helps you to package a native executable with a JIE, with the runtime. And people liked it and used it, especially in the JavaFX world. And that means if you stick to JDK 12 in production, then suddenly you have to update to 13, to 14, to 15, to 16 every half year. And you don't want to do that in production because you would like to stick to something that works, right? So, and that was the reason why they changed it to the 2-year cycle, which is way better. Okay. But what does that mean for security? Any idea? This is JDK 8, this is JDK 9, and this is the number of features in these releases. 56 features and 91 features here. This is because they switched to the modular JDK. After that, it looked like this with the 6-month release cycle. And you can see if you just have 12 features in a new release, it's way easier to test these 12 features for security branches instead of 91, right? The chance that you have some vulnerability in this pack of features is way higher than in this, right? If you just have 5 features in a release, pretty easy to test these 5 features for security or for vulnerabilities in this case. And so the release cadence is also it was a good decision to reduce this to the 6-month cycle. In the beginning, I hated it because you have to update so often and we are not used to that. But now, in the meantime, it's quite a good idea. And with the long-term support versions like 11, 17, 21, it's really good. Okay, and then Java updates. That's the next thing. Who knows what a CPU update is? You should know. You know? Yes? No? Oh. That's a critical patch update. And most of the people don't know it because this is not freely available. You have to pay for that. And only a few companies offer that. And what it is, these updates only contain fixes for vulnerabilities and critical issues. And that's it. And now we come to the different one, which is the PSU. It's the patch set update. And if you download, for example, if there's the next version of the JDK in September, and you download that from the internet, then you get the PSU. This is the stuff that is freely available for everyone, from every vendor. We do that, Oracle, SAP, Tamarind, they all do PSU updates. The difference is this, that it contains also the fixes for the vulnerabilities and also for the critical issues. So what's the point? Well, it also contains fixes for non-critical issues and it contains new features. Small features, nothing like Loom or something like that. But it's like these things, oh, let's add this little thing here, I have an idea, right? And that could possibly introduce new vulnerabilities. I have an example for that. Because it sounds really like, really? Is that really a problem? Yes, it is. And this is how it works. If we take a look at 1702 that came out in January, on top it's the PSU version. This is the one that you can download from the internet for free. It's the CPU version. And you see the PSU contains the CPU, plus it has the features and the minor issues. So that was January. The next release, or the next update, came out in April. If we first take a look at the PSU, it contains all the fixes and some new features, okay? The CPU takes this PSU version and only does fixes to that one, and that's the new CPU. So that means the CPU is always 3 months behind the PSU if it comes to these new tiny features, right? And minor issue fixes. But the idea is that you have another 3 months where this code is already running, was running in production somewhere, and then if there have been issues, they only fix the issues, and that's it. This is just a more secure version, the CPU updates. And then with the next one, it's the same. So the CPU always takes only the fixes for the last PSU. That's how it works. And you can imagine that this is a little bit more effort that you have to spend, because you have to create a separate branch of the OpenJDK code that only contains issue fixes for the last PSU. This is how the thing works, and that's the reason why you have to pay for it. And it's also not always, I would say, important for all the companies, right? If you have a medium or small company, it might not be a big problem. Most of the people never run into these issues. But if you have a bank, insurance company, trading, something like that, where it's really security related, sometimes it's even mandatory for these companies to use CPU updates, because they are not allowed to use the PSUs. That's the reason why we have that at all. And why it matters, there was once the PSU 8U252, that's the old versioning system. And when you installed that, this was the freely available thing, then you couldn't run Hadoop cluster in Solar. It didn't run with this update, it crashed. And that was an official update. And you can imagine if you use Hadoop, and big companies use that, and suddenly you can't run your code anymore. Okay, you as a user would say, I just go back to the old version. That means the old version, the former update, has already maybe some CVEs, right? Some vulnerabilities. That means you open the door, at least for another 3 months, to vulnerabilities. And if you instead had used the CPU, and you see the numbering, if you if you remember that times, because Oracle, for some time, they pointed both of these out on their website. And I was always wondering, what is CPU and PSU at that time? But the 8U251, it didn't had the problem, because that was only fixing issues from the former PSU. And this was one of these tiny new features that have been added, right? And this is one of the examples, and there are more of these things. Like I said, not everybody is affected, but if you run a bank or security relevant company and you run into such an issue, that's really critical in this case. Okay, and now that we talk about updates, let's take a look what will happen if you don't update the JDK. Who here in the room always updates to the latest JDK version? You should. Let me give you an example. So if we take a look from JDK 17 to JDK 17.11, then we start in September 2021 with 17. It came out, general release, nice. 1 month later was the first update. This already fixed 8 CVEs, right? This is just 17.01. That means in 17 have been already 8 CVEs in 1 month. Okay, cool. So we continue. January 2022, another 15. This is not the ones before. This is additional 15 CVEs, right? They are not, all of them are critical. This is low, medium, but still, these are vulnerabilities in the OpenJDK source code that have been fixed with 17.02. And that goes on. In April, another 5, then another 3, and again 5. We are not ready yet. 2, 7, 7. Now we are nearly here. That was January this year. Another 7, and you see it, 3 critical ones with high, and not critical, high, the scoring. And then the last one had another 5 CVEs. That means if you don't update your JDK, right, if you still stick to 17, because you're 17, that's a long-term version, and you have 66 CVEs open in the OpenJDK itself. This is not your software, this is just OpenJDK. So you really should update to the latest updates. That makes really sense, because it's amazing how fast people find these vulnerabilities in the source code. and it will be hacked, right? So that's the problem. This is stuff like log4shell would be one critical, that would be a red one. But even these high vulnerability ones they are quite critical. So you should really be aware of that. So, and people, they say, if it ain't broke, don't fix it, right? Just keep it running. It's okay. Well, I say, if it ain't broke, at least keep it up to date. This is not really a big deal. So you can just download the latest updates and install it, and then you are good to go. And as I said, there are companies, for example, Volkswagen in Germany, first of all, they have to use CPU updates and they have to update to the latest version. This is mandatory in their IT department. So they can't, there's no way around that. So this is, and we have other companies, which is one of the reasons why I think it's only Azure, Oracle, and Bellsoft. These are the only 3 companies that offer the CPU updates. And that's the reason why we do it. For us, it's a lot of work to do it because we have to do the same thing that we do for OpenJDK builds, also for the CPU builds. And for those of you who don't know what that means, you just take it for granted that you can download an OpenJDK update for your Mac that runs on ARM, for your Mac that runs on Intel, for your Linux machine that runs on ARM, for your Linux machine that runs on Intel, for your Windows machine on ARM and Intel, and you are just, this is given that you can just download all these updates. What it means is, for us, is we have to build these things, and therefore we have to pass the so-called TCK. That's a technology compatibility kit that makes sure that Java is Java, right? And that it works and that it's really aligned with the standard. And for this kind of stuff, just one example is you have to run it on a machine where you have a CD-ROM, a DVD-ROM, you have a printer. What else? You need all kinds of hardware that can be addressed by Java has to be attached to the machines for all operating systems, for all versions, and then you have to run all these tests, which sometimes takes a couple of days on each machine to run the tests. So this is the reason why you have to pay for the CPU updates. The next thing that I would like to mention is we have, since JDK 9, we have the modular JDK. And now I have to ask everyone who's using JLink. Who knows what JLink is? That's interesting. Just like I said, it's in the JDK since JDK 9. Let me give you an idea. The idea is to reduce the risk by removing modules from your runtime. And JLink makes that possible. Like I said, it's part of the JDK since JDK 9. It's a tool, it's a command line tool, and you can remove unused modules, right? And that means you reduce the risk for vulnerabilities. If you deploy, I give you a really bad, we come to example. I have an example. The reason is hackers cannot attack what isn't in the JVM, right? So this is that's the background. And I have one example for you. Your application, first of all, doesn't need to be modular. We just talk about the JDK itself, the runtime, not your application, okay? So even if you have the old approach with the class path, not the modules, it will work with a JLink build. And this is JDK 2102. That's all the modules in there, right? And you see it's a lot of modules. And this is 69 modules, and this is 340 megabytes. If you run your application, for example, in a Docker container, and you deploy it on a JDK, then the JDK will take 340 megabytes from that container. And your application will maybe be 1 megabyte. Just think about it. And then think about if it makes sense to have stuff in your JDK that you won't need to run the application. You don't need the Java C compiler and these kind of things, right? Because this is only to create class files. You don't do that usually when you run your code. This is a JRE. That's the Java runtime environment. And you see that's already missing some modules here. Still 50 modules, still 150 megabytes. It's huge. Most of the people use that, right? This is if I use JLink, and this is for a push notification server. You probably heard my watch ringing seconds ago. My son has diabetes, and when he's too low, then it's beeping. This is the push notification server that is behind this. When I use the JLink to create a runtime that's only for my application, because what it does, it just checks all the classes and checks, oh, look, you only need these modules, and then it packs a JRE for you that only contains the modules that your application needs. So with this one, it's only 11 modules, and suddenly it's only 48 megabytes. Right? If we compare that, if I would deploy the push notification server with the JDK, then it would be 339 megs. With the JRE, it's still 150. With JLink, it's just 48 megabytes, and it can be smaller. It can get down to 30 megabytes, depending on what you do, especially when you work with microservices. If they are really micro, then you don't need all the modules in the JDK. Right? So this is a really good idea to take a look at JLink. The way it works, as a short description, so usually, I don't know, who's deploying as a fat jar, for example? Someone? Yeah? So if you have I just take this example. Otherwise, you have to run it on all the jar files. But if you have a fat jar, that means instead of having multiple jar files, you just unpack all of them, and then you pack them in one jar file. So you have all the classes in one jar file, okay? Then you use a tool that is, the name is JDEPS. It's comes with JLink, is also part of the JDK, JDEPS. And it's for dependencies, right? So what it does, you run JDEPS on your jar file, and then it tells you all the modules that you use. And this list you can copy paste and create with JLink from this modules a JRE. Your own runtime for your application. That's how it works. And it's not really complicated, and it could even be part of a build job if you do it, so it's possible. I do the same, so for some tools I do that. It's just a little bit of scripting needed, but you will find description for that. Interestingly, nobody does it. I asked that at DevOps Belgium last year, I had this session. And in the room, I think maybe 10 people raised their hand when I asked who knows JLink. And then maybe 5 of these 10 people said, yeah, we build our own runtimes. And it was, I don't know how many 100 people in the room. So this is really fascinating. And then people complaining about Java is so big, and it's so big in the container. Wow. Yeah, but it doesn't have to be, right? It can be really small. Okay, that leads me to software supply chain. This is a diagram I came up with, which looks very similar to all the others that you will find on the web. So it starts with us, the developers. And usually we get our stuff from a central repository like Maven Central, whatever. Then we have our own repositories, GitLab, GitHub, I don't know, where we submit the stuff, right, or code. And then this goes into a CI/CD build system. And the CI/CD build system also gets stuff from the central repository. And then we have some containers that we create. We put all that stuff in an artifact repository, and then this can go back to the central repository and also in production. So this is, in principle, this is one kind of drawing it, but they are all very similar, these diagrams. All these places are vulnerable and will be hacked. And some of them look really strange. So you ask yourself, how can someone hack the CI/CD build server? When I saw that, I was like, how should that work? Well, there are really tricky ways to get into the CI/CD build system from the outside if you don't make sure that it comes from a secure repository. There are so many ways of hacking these whole things, but all these places are known to be hacked, right? And that means you can find vulnerable code everywhere, right? Because if you can hack all these places, then that means even here, right? Even in the artifact repository. That means you can't be sure that the code is safe, that you download somewhere. And for that reason, you should scan it, right? And I was looking for some facts. That's a little bit older because the session is already more than a year old. This is from the beginning of last year. But Sonatype, they do this Sonatype State of the Software Supply Chain report every year, which is quite interesting. And you can get some of these things for free. And they figured out that over the last 3 years, that means it's now 4 years, and it was 742% was the increase on software supply chain attacks that they could monitor. And they run Maven Central, so they have a lot of code that they can check. And then there is the NIST, the National Vulnerability Database. They also have some kind of statistics, for example, the distribution by severity over time of CVEs, and you see that might also be related to the fact that I bet in 2002 it wasn't that popular to record CVEs, but the demand grow, and that's probably the reason why we see this jump in 2017 here. But still, you see, it was 20,142 unique bugs and security vulnerabilities recorded in 2021, which is a lot. This is not only Java, this is all of this stuff, right? So it means all languages, operating systems, all kinds of things. So if you take a look at the NVD and you look through their database, you will see that they monitor CVEs for all kinds of stuff. It's quite interesting. And this is something that I found just shocking. Because I talked to Christian Grobmeier, he's a German guy, he's one of the log4j maintainers. And I talked to him, and this is already, that was last year in October, I think. And he told me that at that time, still 20% of all the downloads from log4j download the vulnerable old version. Even if it was fixed 21 months before. The issue is fixed, right? People still download the old version. Why do they do that? Probably because somewhere it's hard-coded in some build scripts, the version number, and nobody knows. Some people don't know better. Or you have, for example, transient dependencies. This is another problem. But that's really shocking that even if it was really huge, still 20% of all the downloads download the vulnerable version. And people then ask, for example, Christian, but why don't you just take the downloads away? Right? Just take him from the net. Well, and the answer was he has no idea where the stuff is used, and he can't really guarantee that he won't broke any big system when he just takes it away. Right? So it's up to you, it's up to the users to make sure it's secure. And this leads me to this transient dependencies. That's again from Sonatype, because 6 out of 7 project vulnerabilities coming from transitive dependencies. And transitive dependencies is something like the black box on top is your code. You have a dependency in your build script, you know that. That's the other black one. But these dependencies have, again, dependencies. And that might have another dependency that you don't see, right? And this is transient dependencies. And because you don't know if these are vulnerable or not, you might drag in log4j in a vulnerable version without knowing it. Because one of your libraries downloads still the old version, right? This is the problem. This is from Synopsys. They also do security analysis. And they figured out that when they scanned all the code bases, that at least one vulnerability in 84%, they found one vulnerability. And from that, 48% even contained high-risk vulnerabilities from the code bases, so which is still a lot. And then they also have had some statistics about open source, and they found in the code bases that they scan that 96% of all scanned code bases have used open source, and 76% of that was even open source from the code. That means open source is everywhere, and it is a problem. Why is it a problem? Do you know that? You don't have to read it. I will just show you the important parts. This is a license, right? And it says, is provided as is, without warranty of any kind. In no event shall the authors or copyright holders liable for any claim, damages, or other liability. That's what it says. The rest is just cosmetic. What does it mean? It means I owe you nothing, right? So if I write software, I put such a license in there, put it on the internet, and you find it useful, then I say more or less it's up to you. I don't care if it's vulnerable. And if you download it, you agree to that. But people don't read it, really. And the problem is, this is how open source often works. You probably know that, right? And the interesting fact was the first time when I presented that was in Nebraska, and I didn't know, and then someone started laughing because it says a project, some random person in Nebraska has been thankfully maintaining since 2003. And the whole company is running on this. And this is more or less Log4j, right? So if you use open source, and we saw that we do, then we have to keep in mind open source maintainers are not suppliers, right? So you don't have any business relationship with them. There are no contracts. You agree to their rules. When you download the stuff, you agree to the license, so you better read it, right? And if you use their code, it's up to you to make sure that it's secure. It's not their fault, it's your fault when it breaks. This is very important when you use open source. Because when Log4j happened, there have been a lot of people that blamed the maintainers of Log4j for that. But it's not their fault, right? And they fixed it quite fast. Okay, so what can we do? One thing we can do is so-called shift left. Did someone ever heard that? Yeah, you probably. So let me try to explain it. It's not so hard. This is the software supply chain. We are here. Development, right? Dev. There's ops. The idea is to move the awareness for security more to the left, more to us. And we as developers should be more aware of security. It's not up to the ops guys only. It starts in development already. That's what it in principle means. And the reason behind it is it gets more and more and more expensive if you fix the bug in the end. If you fix a bug in production when the bank already crashed because you have a security issue, that can be very expensive. If you just use something that tells you directly in your IDE while you're coding it, you know what, this code is vulnerable, that's cheap. This is the reason why shift left is one approach to make it or to help to secure the software supply chain. So that means DevOps became DevSecOps. And if we take a look at this, you probably saw this loop, then it's the dev part starts with planning, coding, building, releasing, and then we come to the ops like deploying, operating, monitoring, and then back to planning. Then where's security here? Security is everywhere. Security belongs to all of these things, right? There is not really a left, right, only ops, only dev. So security is for all of us. We have to take care about it. So shift left, yes, but also validate right. Validate right, I will come to that in a second. So first thing we have to do, update your JDK. You saw how many CVEs are in the OpenJDK itself. And it's cheap, it's for free. Just download it, install it, done. It's 4 times a year and you're good to go, no problem. And there are tools that can help you. Who knows SDKman? Yeah, probably only the Linux users because it's not available on Windows. It's for Linux and Mac. So it's a tool that can do way more than only helping you downloading JDKs. It can also help you with all kinds of libraries and frameworks. But what they do is, it's a tool to install a JDK and keep it up to date, right? So it's a command line tool only. It's for Linux and Mac. And it downloads and installs JDK. There's, I think on Windows, there's something called Chocolati, which is similar to this. It's not the same, but it can do similar things. And because I'm lazy, I also wrote my own tools. And this is a Java tool. That was the first approach. That's so-called JDKmon. Because I also wrote an API that contains, or that has the links to all the distributions that are available, Disco API. And then I was lazy to look up all the time, because I have a lot of JDKs on my machine. When is the next update? Where do I have to download it? And all these kind of things. Sucks. I was too lazy. I needed a tool that reminds me and then give me the opportunity to just click and download it from there. So it supports all JDK distributions. You can download it. You can also download other JDKs with the tool. It's a taskbar application. It's for Windows, Linux, and Mac. It's written in JavaFX. And it's free, available on GitHub. I have to be honest, I don't really maintain it at the moment anymore, because as you see, I'm working on Mac. And I thought, because this was really not so easy to make it look like a native Mac application, with the taskbar and all these stuff. So I was thinking about something else. And it also shows CVEs in OpenJDK. So I just applied for an API key for the NVD, the National Vulnerability Database, and now I can look up. It's a little bit complicated to look up these keys that they have, for example, for OpenJDK. But I did that, and now I can. This is how it looks on the Mac. On Windows, I try to style it as a Windows app. The Linux version looks the same. So it shows you all the stuff that is installed on your machine, the JDKs. Also GraalVM, this also supports JavaFX. If there's a new version, it tells you there's a new version, and then you can download it. Either if it's available as a tar.gz or zip, you can download it there. If there are vulnerabilities known for this, you will see this little box. If you click on it, it will show you the CVEs, and then you can click on the CVEs, on these bubbles, on the colored ones, and then it will open the ones in the browser so that you can look it up in the NVD. This is JDKmon. Like I said, this is the Java version, but because I'm on Mac and I would like to have something different, I also created JDK Updater, which is in Swift, and this is a native Mac application. It does exactly the same, but only for Mac. So because it's in Swift. So you don't have to go through that, it's the same stuff. But this also supports widgets. This is how it looks now, but you see this is a little bit different, but this is a native Mac application. It can do even more. It shows the default JVM that is per default on your machine. In this case, it's GraalVM community. It shows you if it's a LTS release, it's green. If it's not an LTS, it has no color. It shows you the architecture, because you can install on a Mac, even if it's an ARM Mac, you can install an x64, so an Intel JDK, but you won't see it. So it will just work. The Mac OS makes it work, but I can show you if you have the right one installed. And then you see the same stuff. It's the version with the download bubbles, and again, you have this little thing where you can click on, and then it shows you the window where you can. It's more or less the same. It has some more features because it also gives you an overview of all the projects that are in OpenJDK and all the JEPs. So you can look it up, you can click on it, it will open it in the browser. So it's helpful if you are into that, and if you're on Mac. Oh, it can even do more, but that's too much. Other tools is static code analysis. Who knows find bugs? Someone? No one? That's yeah, it's a little bit older. So usually this is part of a code review. So white box testing. It's used to identify vulnerabilities in source code at the implementation phase. So that means it is quite cheap, because it will tell you already in the IDE that your code maybe is vulnerable, right? And it's available as standalone tools or IDE plugins. This is just a list, and this list is from the NVD. They have, and they say this is just a list, it's not the list, right? That doesn't mean this is the only tools that are available. This is the tools they come up with. And you see there are some free ones, and there are some paid ones, and some have both of them. It's just some of the static code analysis tools that are available. If we take a look at, for example, find security bugs, that is, I think it's it's a spot bugs, and spot bugs is the successor of find bugs. It's quite complex. Yeah, it's free of charge. It extends spot bugs. It can detect more than 400 bug patterns. Is a plugin for your IDE. What's that? I thought I have a screenshot. Probably not. Let me see. No. Okay, no screenshot. So this is just one example. So it is helpful, static code analysis, but if you would do better, then you should use a so-called vulnerability scanner. So the difference here is these detect vulnerabilities because they use databases, either their own ones, or they use the the NVD, for example, to look up stuff. And they can even probe for vulnerabilities, some of them. So they can monitor misconfigurations and coding flaws, help using only artifacts from reliable sources, which is also quite useful. If you remember this NPM thing, what was it? Something with left. pet left, I think. Did someone remember that? There was something in NPM which is JavaScript, and it was called pet left. And a guy who created that never thought that this was part of NPM and was used everywhere, and then he just removed it. And suddenly, half of the NPM people that used NPM to build something, the code broke because of that. The reason was he hosted it on his own server, and when he removed it, then NPM couldn't find it anymore, and that it was gone. These tools can help you to make sure that this comes from reliable sources, not from some private server somewhere, right? It helps using only latest secure versions without known vulnerabilities. It monitors appearance of new packages with fixed vulnerabilities, so it can tell you, for this library, there is a new version available that fixes this and that CVE, for example. They can update even dependencies for you, right? You don't have to do it then on your own. So where they work, so the security scanners can work directly in your IDE. They can scan and fix on repositories, on the CI/CD build systems, and some of them can even do artifact repository scanning, and they can monitor in production. The problem is, if you do that in production, they probably use a so-called Java agent, right? And the problem with the Java agent, just shortly, if this is the JVM and it's a black box, right? Of course it's not. It has different parts, and the upper part is the class loader subsystem, for example, right? And you see the loading part, and there are the different class loaders. So that means if a class is loaded in the JVM, one of these class loaders will be used, or a custom one. Now, the JVM comes with an API. Not everybody knows that. So the JVM has a so-called instrumentation API, and you can talk to the JVM when it's running, right? And to do that, you use a so-called agent. It's called Java agent. It's a Java program that can talk to the API and can talk to the runtime while the runtime is running your application. You can already get the idea that might also be dangerous, because if someone from the outside can talk to the JVM while your application is running, right? You can prevent that, but this can also be used to scan for vulnerabilities. The problem here is that the agent adds a callback to the class loading system, right? Because it needs to know what was loaded. So that means every time a class is loaded, the JVM will trigger the callback and will tell the agent. And that comes with an overhead, at least 10% most of the times. Because you can imagine every time classes are loaded, it goes back and forth and back and forth. So it's really a lot of overhead that comes with these agents. And that's the reason why nobody's scanning in production. So here are some of the vulnerability scanners. We have one, Black Duck is quite popular. Sneak, SonarCube, these are the popular ones for Java development. And if we take a look at Sneak, for example, Sneak Code, then there's a free and paid version, and they support more than 9 languages. And they have quite a nice idea. They have this developer first approach, which is more or less shift left, right? This is for us. And you can see it. It's very convenient. The plugins are nice. And as a developer, you see it and you feel comfortable with it. It's not really a security tool. It feels more like a help for you when you code. And even the free tool is already good. This is a standalone version, and it's also as an IDE plugin. So I can just recommend installing the free IDE plugin. It's quite useful. It stops at CI/CD integration. So they can't do scanning in production. The reason is they know about the agent problem, and they said, no, we don't go there, because then people won't use it. Because it's just, if you run something in the cloud, and then you scan in production and you have to pay for 10% at least lower performance, then probably one of your managers will say, nah, we don't need to scan in production. Let's scan only in CI/CD, that's good enough. So this is what usually happens. And this is how it looks like. It's not really that important what you see here. It tells you where's the problem and what is the problem. Right, this is a plugin. This is now JavaScript. They can also do JavaScript. This is JavaScript example that I found. But this is how it works, right? You have this specific Windows. This is in IntelliJ, and they tell you where and what. And then there's SonarCube. That's another big one. Very similar. Again, free and paid. They have more than 30 languages, even more than 4,800 analysis rules, also standalone and plugin, and they also stop at CI/CD. They don't do scanning in production because of the same reason. It's too critical performance-wise. This is how it looks like. Again, you don't have to take a look at what you see here, but they tell you again where is the problem, what is the problem, and then even why. They give you more explanations here. It's a quite powerful tool. But probably, I never tested the free version, so I just know people that use the paid version and they are totally happy with it. Even with the Sneak tool, of course, this is also good. But I just use the free Sneak version, which is fine. And then there's our own vulnerability detection. And what is the difference here? We only scan in production. We don't do anything else. And we only can do Java. So only JVM, not Java. So everything that runs on the JVM, we can scan. If it's Kotlin or Scala, whatever. If it runs on the JVM, we can scan it. And we have less false positives. So I will explain what that means. Because false positives means that if you have, usually it works like this. You have this blacklists in the security departments, and then they have this list of stuff they have to check. And lots of the stuff isn't a vulnerability, right? But you have to check them all to make sure it's not. So this is the false positives. Because they don't really know for sure if it's a CVE or if it's a vulnerability. So we did a different approach because we saw that nobody's scanning in production. So, and because we do JVMs, we thought if the JVM loads all the classes anyway, as we saw with the agent, why not let the JVM just talk to some other tool, which is, we name it the forwarder, and you will now say, well, where's the difference to the agent? The agent installs something like a hook that will be triggered every time a class is loaded, right? We did a different approach where the JVM, when it's loading stuff, from time to time just talks to this forwarder and tells the forwarder, yeah, I loaded this stuff. And once it did it, it doesn't do it again. So if I loaded one class, I don't have to tell the forwarder again because I loaded that already. And then the forwarder does the heavy lifting and talks to a cloud service. And so your application can run without a performance overhead, and we can scan in production. And this is just one example what we can deliver. So it comes with an API and you get this web UI. And we can also tell you, of course, where's the problem. That means the library, for example. And we can tell you also the CVE scores and all that. And now we can tell you something that the others can't do, because we can tell you if you use it or not. And that's the difference. If you have a CI/CD scanner, they check all the dependencies on your build scripts, even with the transient dependencies. And then they tell you, there's log4j. That's vulnerable. You have to exchange it, right? We can do exactly the same, but we tell you, yeah, you have a dependency on log4j, but you never load it. Because the JVM doesn't load it, and the JVM knows it, right? The JVM knows, oh, there's a dependency. I never loaded a class. So you're safe still, but you have a vulnerable dependency. That's the difference. And why is it important to scan in production? If you only scan in CI/CD, and let's say you build once a week and deploy, then you deploy today. And let's say 1 hour after your deployment, there is a new CVE. Then the next time you will be aware of that is 1 week later. And for 1 week, you're open for that. That's the reason why scanning in production makes sense, especially with Java, which is quite dynamic. It's not a bad idea to also scan in production. So a secure software supply chain could look like this. So you use, for example, third-party libraries like log4j or Spring, or you have even products that are based on Java, like Cassandra or Kafka, right? If you go to Kafka Summit, right, it's a conference just for Kafka users, and then you ask them if they know that they use Java, and they say, no, I use Kafka. Yeah, but Kafka is running on Java. So they have no idea that they use Java under the hood, right? So if you have this, then you could use, for example, Sneak or Coverty or Contrast as a code scanners, and you can use the same, or Black Duck for CI/CD scanning, and then for container scanning, there's also something like Anchor. And in production, you could use the vulnerability detection that we offer. So then you have shift left, right? So that means this part takes care about scanning all your stuff. And this is validate right, because we can prove if this was correct. If the CI/CD scanner was right when he said, oh, you have a vulnerable dependency, now we can tell you, yes, you have it, and you even load it, right? Because it doesn't sound really that critical, but there are companies that have dependencies on libraries, and they can't change the library because it's a third-party dependency. And these dependencies might have vulnerable dependencies. And that leads to the fact that my product suddenly has a vulnerable dependency. And I know it's not used, but I can't tell that to the CI/CD scanner. There's no proof. CI/CD can't do that. We can do that in production. That's the difference. So the takeaway from that session is you should really follow an automated patch schedule. Usually take this every 3 months, updates of the Open JDK. Just update your JDKs. That makes sense. Automate application packaging with JLink, right? So create your custom runtimes. It's very easy. I don't know why don't people do it. It's like 4 lines of script code and you're done, right? It's very simple, but nobody does it. Watch out for CVEs and libraries and stuff. So if you have a security department, they will do it, but if not, then it's up to you to be informed. And use vulnerability scanners, right? You don't have to use them in production, but at least use something for security stuff, which is really important. So that means, do you need to be a security expert? No, but you need to be aware of security. That's the takeaway from that session. And with this, stay secure. And I'm done. If you have questions, then feel free to ask me. And if I can't answer him, he will. Thanks. So any questions? Yeah. This is coming, right? So it's the tools like Sneak and also SonarCube, they come up with that now. We don't have that. It's because when we started that, this was not really for us a topic, but this is definitely important, yeah. But I don't have any information about the SBOM. So I just know that SonarCube is working on that. They have a tool. I saw that at a conference. And I know that Sneak is also working on something. Or they already have, I don't know. So the question, yeah, it was a software bills of materials. That was the question. But I don't have any specific information about that. So I just know that SonarCube and Sneak have something. Probably Black Duck has something too, because this is now the thing. Everybody's asking for that. Any other question? And if not, it's also okay. Okay, then we are done.